Hello everyone, this is Likit. Today I would like to showcase a project I built, Manim AI Video Maker. Manim AI Video Maker is a website built using Stack and Manim. As you can see, there are basically three components here: video creation guide, script, and video preview. To explain briefly about how this project works is you give a prompt about what type of video you would like to make here in video creation guide. Then you can refine it or send it as it is. Then you click generate script to generate your first draft script, which you can modify, or click generate video if script is alright to you. Then in your video preview you will get your video. So let's see it's working through an example. We can say explain, let's say, two pointer approach. Then you can click refine prompt here. After that the refined prompt will come. You can edit it if you want. Then you can click generate script. After that you will get the generated script. You can look how it divides into speech, scenes, and the title of the scene, what are the visual that follows, and the speech that has to be spoken. All of this will be generated using AI. We're using Gemini TTS for speech and Gemini 2.5 Flash for Manim video generation. You can click generate video here. This would take about 3 to 5 minutes.
Ever faced a problem where you need to find two numbers in a sorted array that add up to a specific target?
So as you can see, the video is generated after about 5 minutes. Sometimes it would take faster, sometimes it would take longer, depending upon the video you would like to make. Now I would like to show you the code behind the project. So here we divided backend and frontend into two folders. So servers.js is our main logic which coordinates all the backend and frontend part. So first I would start the explanation of code using frontend. Here under components, we get our four main components: the video viewer, the script viewer, the prompt refinement, and the audio viewer. The audio viewer is not visible, but the generated video consists of both video without audio and the audio, which is then again stitched using FFmpeg. So these are our front end components. Coming to our backend components, as I said, server.js coordinates the front end with all backend files. Our first backend file we would look into is prompt refinement. After you enter the required prompt and then click refine it, it uses this system prompt and AI. I use Gemini 2.5 Flash. This takes the system prompt and refines that prompt and gives to you back in the prompt refinement box. Then after you click generate script, the logic would be redirected through server.js to scriptlogic.js, where we get the refined prompt and uses this system prompt to generate our script. It generates it divides the script based on scenes, and it gives each scene a title, what visuals it should showcase, which are Manim compatible, and the speech that need to be displayed or spoken. For speech, we use Gemini TTS, as I said before. And after generation, after script logic, when we click generate, The speech part would go to TTS logic, where the Gemini TTS generates the audio file and it is saved in media in the audio section. And then the video part would be generated in Manim logic, which again uses the system prompt and generates a Manim code, which we saved in code. Then this code and this audio is stitched together using FFmpeg, and then we get the resultant video. Hello. Now I would like to showcase the GitHub repository for it. So to get into this GitHub repository, first you have to search Likit 9010, which is my username, then Manim AI Video Maker. So you can raise PR requests on a bunch of issues, which I would explain in a minute. So you can clone this project, use it, modify it as you please. It is released under MIT license. So in what issues you can raise PR requests is I forgot to add a README, so you can write a good README and send me a PR request. Or there are some improvements which are needed. Basically, right now I'm using V1 endpoint to use Gemini 2.5 Flash, which for some reason is not compatible to use Gemini 3.0 Flash. If you have any knowledge about that or any code need to be changed, you can raise a PR request or explain it in comment section. Also, the video format you're seeing is I purposefully made it in a in a YouTube Shorts format too, because I upload the videos from this project in my YouTube channel. So you can make it the dimensions into normal video, traditional video format, and also the 2 minute limit is set up. You can you can remove that limit and can set up to 10 minutes by changing the system prompt, and also using better API key than 2.5 Flash. And also another problem that arises in this project is to for the audio to match video. In the script selection, we do give that divides based on scene what audio need to be matched to what visual. Though we are giving a script and giving it exact timeline, but it's not always the case that audio and video matches. Maybe you can look into it and improve the logic, and you can raise a PR request. I would personally look at the all code, and then I would merge it if it's an improvement. I did make an app so that everyone who is interested in project then that can go to it and experience it. But currently it's down due to my Google Cloud account, some issue with it. So thank you guys. This concludes the video. Hope you had fun.
Hello. Ever wondered how to efficiently solve problems involving pairs or subsequences in a sorted array? Today, we're diving into the two-pointer approach, a powerful technique that uses two pointers to traverse data, often from opposite ends. It's incredibly efficient because it helps us narrow down the search space quickly. Let's illustrate this with a classic problem. Given a sorted array and a target sum, find two numbers in the array that add up to the target. For our example, the array is 2, 7, 11, 15, and our target sum is 9. First, initialize a left pointer at the array's start and a right pointer at its end. We calculate the sum of elements at left and right. Here, 2 plus 15 is 17. Since 17 is greater than our target 9, we need a smaller sum, so we decrement the right pointer. It moves to 11. Now 2 plus 11 equals 13. Still greater than 9, so right moves again, this time